Today we're talking about AI-assisted data engineering, especially in the streaming context, which is super interesting. I have Tun here with me, and let me bring him on the screen. Hey, Tun.
Hey, Andres. Hey, folks at home.
Hi. We were actually, before we get into the whole AI assisted engineering topic, we were talking yesterday about what we're going to say here on the stream and what you're going to show us a bit about your road from software developer to actually data engineer and then here as an AI engineer. And I think that is super interesting because that's the trend right now, right? Everybody's talking about, should we become an AI engineer? How do I become an AI engineer? And I think that's a super interesting topic. Like, what was your process in this?
Right, yeah. I guess the backstory here is I was a software engineer for about 12 years. And around about 2015, there was an emerging kind of job title I saw in the market called data scientist. And I thought, wow, I want to work with that fascinating creature. So I started, I guess, my data engineering career at that point. And it was working in cross-functional teams with data scientists. Prior to that, like I was coding in Scala, so I was doing functional programming in Scala, and Spark just happened to be written in Scala, so it was like a natural progression into data engineering for me. And yeah, that's how I've spent the last 10 years. AI engineering, a fairly new term, I think. Like not so well defined, I guess, out there, like all new kind of job titles. But I started getting into working with LLMs and understanding how they work for the past year. So that was kind of like my roots, and fairly straightforward, I would say.
Yeah. For me, it was actually the other way around. I knew I had to use Spark, and Python wasn't really good at that time. And then I got into Scala from the Java background, and then that whole thing took off for me.
That's the
As you
same
said,
yeah, it was a Java background for me. It was like a good 10, 11 years in Java land. And then, just Scala just made sense. It was like the language like I didn't know I wanted. So that made it so much easier. I should add as well, like somewhere in between, there were this job title called ML engineer, right?
True, yeah.
Who would be responsible for productionizing the research from data scientists. So I think people forget about that role. I almost did just then. But that I would say is the closest kind of to an AI engineer today.
Yeah, it's for me. It's right now as well. Like it's not so well defined. When people are saying AI engineering and here and there, and you see it on the it was actually also on the Gartner hype cycle, and so on. So, but like the definition isn't 100% there, right? Because we were talking about this stream that we talk about MCP servers and talk about agentic systems, and everything is like it feels like everything is thrown together.
Yeah, it's moved so rapidly. Like MCP is only like around 11 months old. So I think in the space of like 14 months, something like that, there was just one after the other, like new startup upon new startup, new release. And you can see OpenAI's releases even in the last like 4 weeks. They've shipped so much. So I feel like there is a lot of fatigue out there. So yeah, my advice is always with anyone who works in engineering is just to get stuck in, figure out, because I always get questions like, which LLM should I use? So there are benchmarks out there. There are published benchmarks you can go and read, websites that make it really easy, like LM Arena. But it's a personal preference thing at the end of the day. It's like how you communicate with an LLM is very personal to you. So I feel like just using things, trying things out is the best way ahead.
Yeah, that's true. The thing is, though, or not though, the thing is you have to try it out, and then you, for instance, see, okay, when people talk about MCP, it's not that big of a deal. Like it's a definition, and once you understand how to use it and how it works, people make a big thing out of this. But
yeah, I hear that a lot as well. I think MCP has just been so popular. So just to bring everyone like up to speed, so Anthropic brought out this open protocol called MCP, Model Context Protocol. And what it enables LLMs to do is suddenly have hands. So if you consider the LLM the brain, it now has tools and hands to actually take action. And that was kind of like a missing link, I think, for a long time. Like the world got accustomed to tools like ChatGPT, I mean, which was a runaway success. but it couldn't do much beyond generating text, right? So how do you help LLMs to take action? So MCP was created specifically for that reason. And I think why it's been so popular, so the metrics say it's been about something like 10,000 plus MCP integrations to be created in like 10 months. It's insane. And I think it's partly due to its simplicity. It's really easy to do. I always describe it like playing the piano or even the guitar, like, because I know you play guitar as well. It's very easy to start a little simple melody, but to write like a full-on like symphony, it takes time. So I think it's easy to get started. To productionize it, whole other set of challenges.
That's true. Yeah. I've also, the context very often in these is not a streaming context or working with streaming systems. That's why I find this so interesting that we two talk here today, because you, from the Lenses background, you work with streaming, you guys work with Kafka. And for everybody who's here, we had, or you can look more into that when I did the live stream with Drew. Drew is a colleague of Tun, and where we went through how to set everything up and how to basically look how these pipelines perform and so on. So I think that context is very interesting to say, okay, I want to integrate some AI engineering, to come back to our initial title of this event, to implement this, because I guess it's a bit different.
Yeah, Drew did a great job of explaining how Kafka largely is like a black box. Like it's not like you can query it, and it's only kind of in the last few years that there were SQL engines that were built on top of it, and Lenses is one of those SQL engines. So you build them, you're able to use SQL to introspect and see what's happening in the cluster. So we thought we'd extend that to the AI layer. So a lot of teams had built and productionized around this concept of a SQL engine to query Kafka data. And we built all the governance, all the IAM, the permissions, the policies around it. So it becomes very secure. And then it was just a matter of extending it to a natural language interface, really. So that's really what MCP enabled for us.
It's an interesting topic because, like you said, there's already SQL there. That was already a jump, right? From having streaming data, and it was super difficult to look into what is actually happening, what's right now in the message queue, and get the data, to, okay, now it's easy to explore. And the next step, to make it queryable via natural language. And just last week, I was talking with someone who was asking me, like, okay, now we have Snowflake, for instance, as a warehouse. Can I just do the same thing? Right? Can I use, instead of using SQL, can I use natural language? Can I use some kind of an agent to talk with it? And that whole concept is an interesting concept, that this is coming everywhere right now, isn't it?
Yeah, definitely. I would say even with SQL, it felt like a very natural abstraction. And there are even companies to this day that are getting funding to create like a unified kind of engine between batch and stream. And when I first saw SQL engines in streaming databases, I thought, surely that's the last stage in that evolution. Like everyone's going to jump on streaming at this point, but it just didn't happen. And I think it's just because that complexity is really difficult to hide. Because to understand real-time systems and Kafka and streaming systems, you need to understand distributed programming. Like that's a whole other topic, right? So to understand that takes some work, and it's not easy to abstract that away in SQL even, because you still need to know about windows and even partitions. But with natural language, it kind of changes things. I've seen I hosted and emceed a hackathon in New York last week, and we had about 30 people forming teams, and like pretty much none of them had worked with streaming data. They'd heard of Kafka. They always thought it was a complex thing, but to be able to access that data using MCP, natural language, they just thought, wow, why didn't I do this sooner? It's like, well, it didn't exist before. We had SQL and you didn't do it. So what it took was MCP and LLMs in natural language. So maybe we're going through this kind of paradigm shift. People are like, well, I want to talk to my data. I don't want to write a query. And it doesn't feel like you're writing a query when you talk to it. I think that's hopefully the last hurdle.
Yeah. Let me quickly bring something up. I did a poll earlier on, and that was like earlier today. I just wanted to see, in preparation to our talk, do all data engineers have to become AI engineers? Right? Because for me, it feels like everybody needs to become an AI engineer. Everybody's talking about it. 31 said yes, 43 said no, 26 said not sure yet. Right? So for these 31 that think you have to, and like what should you do? What's the right concept to get into AI engineering?
Yeah, I think kind of AI is everywhere, and AI assisted tooling is everywhere. And I feel like that's the first step. If you think of it as like a hierarchy of needs, like right at that base of the pyramid, I think everyone's got to try out ChatGPT, start trying to connect that with their data systems using protocols like MCP, and starting to build around that and start creating actions like intents and tasks around natural language. And I think that's the first step. And I think that covers nearly every role. So if that's why people say yes, then I think that's not quite there yet. But to go all the way, I think it's really just understanding another tool in the toolkit. Much like I guess for me, and I guess I'm a classic like big data era kind of data engineer. Like Spark is part of the data engineering tool set, whereas someone else might disagree and say, well, it's actually more like DBT or using like data warehousing. So I feel it's not very clearly defined yet, but I do know the answer is somewhere between ML engineer and AI engineer. And I do know that when LLMs were first released, a lot of NLP scientists and NLP engineers and natural language processing engineers, they all suddenly had this instant like existential crisis because they're like, well, a lot of our work can be done almost overnight. So what do we do now? So I don't think we're at that point with data engineering and AI engineering. But I think it will just we'll be applying our knowledge like in different ways. I feel like our knowledge of distributed systems, how to manage things in production, observability. I think it's all those important things will come in, but in a different way, in a more like non-deterministic kind of system is what we'll be dealing with. So it requires a different approach.
A different approach. Interesting. Let's see where this goes. From a tools perspective, because Ruben was asking you which tool should I learn to become an AI engineer, I'm always very anxious to use these definitive things, learn this, and then you're an AI engineer. But like we were talking about, you said MCP is important. Is RAG an important concept for you that somebody absolutely needs to know?
I would say in the path to an AI engineer, yes, it's one of the approaches that should be deployed, and it has a space like as a solution. So absolutely. We're going to talk about context engineering in a moment, but it kind of plays into the whole, how do you provide data to the LLM? And that is an AI engineer's job. So I would say yes. Around tooling, I would say you've got to figure out what your favorite kind of AI assisted code editor is. I think if you want to become an AI engineer, like personally, I've never met, and this wouldn't make sense to me, if an AI engineer said they didn't use an AI assisted IDE or code editor, that's almost like the litmus test. I think if they say I'm an AI engineer and I just use VS Code, and I'm like, VS Code, like with plugins, and they say no, I'd be like, it creates some doubt. So I'd say like working with different LLMs, figuring out like what reasoning models you like, what fast kind of flash models you like. I think that's the first step. Those are essential tools. We can talk about frameworks as well. I often get asked like which agentic framework should I use? And there's so many to choose from. Sometimes I say use no framework or use something really lightweight. Like the one we used at the hackathon, it was with AWS. They brought out one called Strands Agents. It's super lightweight. And I tend to favor anything lightweight because I feel like it's very early as well. And I think a lot of how we think about tooling will change in the next 12 months. So I feel no framework and lightweight framework is the answer right now. So sorry to not be so specific, but it is a preference thing. But I feel like I don't want to put all my eggs in one basket right now, but I know lightweight's the answer. Really.
That's true. We need to see where this is going. That's the big thing, because like it's so early that there are so many solutions out there. And if you now focus on a specific one, it's difficult. But generally, I mean, when we were talking about, or no, one thing I wanted to say, and I wanted to ask the chat here as well, like which AI assisted coding environment are you guys using? That would be interesting for me, because I still have a bit of problem with that topic. Whenever I use it, I get the feeling that I'm losing touch with what's actually happening. And for me, I'm more of a, where I use this a lot is in the stage where it's not necessarily the building. Yes, the building is, but let me say this differently. I think the IDE is one part where getting it up quickly, but you have to understand what you're going to use. And that's why you said, don't go into a single tool because we don't know where this will go. And to understand the basics as a good AI engineer, then the doing is easy. That's just getting support from the AI, and before understanding which model to use, which transformer to use for a RAG application, those things are important, don't you think?
Yeah, I think like knowing things from first principles, there's no substitute for that, because you've got to remember LLMs and that transformer technology, they're great at predicting the next token, the next set of words. That's what they do. And they will try to please you. So, I mean, that's why like vibe coding is a very interesting concept. Like you just accept everything that's given to you. And sometimes you learn to be specific and sometimes you forget and you're vague, but you just kind of accept what you're given. And yeah, I think like vibe coding, I think has its place. Like one place I've identified, especially with our customers, is like with engineering being a finite resource in any company, and that's the reason why you have whole industries for this, like MarTech for marketing technology and sales tech, like Salesforce. You have all these things, all these industries exist because software engineers don't want to do that work sometimes. Like sometimes they might find it boring. It's not the sort of interesting challenges they pursue. So there are whole industries that make this easier. But then day to day, how do you help these departments, these teams? And vibe coding is a really good, elegant solution for that, because usually the solutions they need only need to last for one day. So you can vibe code in the morning, use that solution. For example, like you're trying to just get a ranked list of prospects or people you want to contact through a campaign. You're able to do that. You can throw it away, no technical debt, which is great. And then next day, rinse and repeat. But the important thing there is, much like a product owner, the subject matter expert, the business owner, is the person who really understands their domain. And sometimes, that is lost in translation when you create tickets and you got to get an engineer involved, and it's quite open to interpretation. The software ends up being imperfect anyway. And so why not have something that you can just throw away and iterate on very rapidly in the morning and test and verify it's working? So I think that's probably like the radical take I have for you today. That vibe coding has its place. Like a lot of engineers may disagree, but I think it helps business teams a lot.
For me, it's difficult because I'm always looking at this from a developer perspective, and I get chills when I think about this.
Like as we all should, yeah. And I do, and it took me a while to get to this. Like it was difficult to understand, but when we build software to solve problems. And sometimes they're business problems, and when they're working, I can't deny that, right? But part of me will always be like, right, there has to be engineering rigor in this, but that line becomes a bit blurry. Like where you stand on that line, like changes, I think, over time. And I'm open-minded. I'm open to it. So yeah.
I think for the use case, as you said, if it's something quickly, like, let's say you just want to get some data out of Kafka here, right? And you have a system that can quickly dock on, do something, and it's not a workflow that you have to use multiple times. It's just a one-time thing. Okay, let's quickly ask the agent or the MCP server. Let's quickly ask it through the interface. What is the answer for this? And it gives it. That's a good use case for this. On the other side, like I also feel whenever you do something that has to last longer, you need a kind of a level to understand what's going on. Otherwise, you're going to be in big trouble. So the complete vibe coders that have no idea, let's say, one example is website creation, right? I was working on our website. I know a bit HTML, I know a bit CSS, so I can see, okay, this makes sense. But if you're going in completely blind with just vibe coding, I don't know.
I mean, if you go into the right, depending on how you look at the right or the wrong subreddits, like into the corners of Reddit, you'll find people who've built their entire business on vibe coding, and they're earning like insane, like serious money. This is not an endorsement, by the way, because I don't believe in it, but built on quite fragile technology that has to survive each day, each subsequent day, whilst they add more features to it. That's pretty scary. That's playing with fire.
That's true.
Like, I would never recommend that. I think it's great because it's giving abilities to people who can't code and maybe have, a good head on their shoulders around product. But engineering rigor can't be substituted for anything that should have longevity. Beyond even a day, maybe even a week. Like after that, it becomes difficult.
True. Let's quickly go into one of the questions, and then we wanted to talk a bit more. You want to talk about context engineering. We also want to talk about agentic systems where they're different than traditional APIs. One thing that Amit here was asking, what type of practical AI ML projects would be best to showcase that transition?
That's such a good question. Yeah, thank you for that, Amit. I think when we're talking about AI projects and agentic systems, the best examples are always the open world problems. So the thing that I always say is with the rise of LLMs and AI engineering, we're able to create applications and platforms that couldn't have been created before. And by that, I mean systems that you couldn't have programmed with logic before because it's just too vast. To give you an example, and it comes from NLP, a lot of companies that, they had a chatbot product. So for example, if you're a fintech, you might have a chatbot product. To make sure that chatbot remains accurate and efficient and doesn't drift, you have to retrain that data. And if you have something like a classifier in there, which basically determines it's one of these things in this set, over time, when new classes appear in the wild, and as a natural state of evolution, you have to retrain that model. But with LLMs, because it's all semantics, they suddenly start learning and figuring out, okay, this is a new class, and that has like profound implications for any sort of industry where you have to start classifying, for example. So I think classification is a really good thing. So named entity recognition, being able to extract and understand what things are, those are generally good ones. I'd also say because of the non-deterministic nature of AI, I would say any sort of project that has like a fixed scope can be quite isolated and is quite tolerant of failure. I think those are the really good. So quite limited scope kind of projects are really good. You've got to remember with tools like ChatGPT, that's a data product you're using. You're not actually using an LLM directly because LLMs, they're inherently stateless. They don't remember anything. So what is happening is every time you add a new prompt in that window, what's actually happening is the product itself, ChatGPT in this case, is sending the whole conversation history every time. And for those of you who are wondering why you're blowing through your context window so quickly on your subscription, that's the reason why. You have to clear down or create a new session each time. And so all that management that happens behind the scenes, I mean, that's context engineering, which we'll get onto. So anything where you have something that is quite open world, I think are the best examples, something you can program.
I used for what I did in my academy as last project was a RAG system where we were basically extracting data from CVs that I made up with ChatGPT and then embedding them into a store and then asking questions about the people, asking questions about who can do what. And these, I agree, these examples where it's a very closed project.
Closed system, but wide, system. Like could be, you accept any kind of input. So I think that's another, I guess, another way you can define it. Yeah, you accept any sort of input. So unstructured, structured, and yeah, you're relying on the LLM to figure out the semantics to figure it out. Those are great. Yeah, CVs are great example of that.
Let's quickly dive into the context topic, because I think this is something that a lot of people need to understand, because I'm guessing also this was difficult for you guys when you implemented that kind of chat functionality on top of Lenses, because you want to ask about maybe what did I tell you, or what did I query a few chats ago, or reuse something, right?
Yeah, makes sense. Should we share the screen? I've got a few slides I can just show, yeah, because it helps to just illustrate my points here. So when we're talking about MCP, so that's the logo for MCP. It's pretty cool there. You see, it's a thing that sits in between any sort of system and an LLM via like a product, like an agent or an IDE. So that's kind of like the scope of things and where everything sits in the world. When we talk about context, we're talking about an LLM and a context window. So I really liked how Andrej Karpathy put this, like how he considers this is all an operating system. So the LLM is like the CPU in the operating system, and the context window would be like the RAM. It's the memory, and you kind of fill it with instructions, knowledge, tools, things that it can call. So that's kind of like where we're at. And this is context engineering. So that big circle. So this is from Philip Schmid, who works at DeepMind. And this is context engineering. And of course, you can see RAG in there as well. That forms part of that. And you look at all these things that like you can do to fill up that context window is, it's staggering how much there is. And to define things, let's start with the definition. So context is everything that an LLM sees before it generates a response. Therefore, context engineering is building data systems that provide the right information and tools in the right format to an LLM so that it can accomplish a task. So RAG is one of those ways. It's how you retrieve relevant data based on what's being spoken about or the current context. And you invariably have to manage different other sorts of states. So long-term memory is so RAG is powered by vector databases and vector search. And I feel long-term memory is another similar thing. Like if you have a really wide, really big history, like to find those moments in time, you have to do some sort of semantic search. So there are lots of similar things. I think the thing to note is context engineering kind of, I guess, was born out of prompt engineering. That was how everyone used to do it. And you can see right there, user prompt there in purple. And then in yellow there, you've got system prompt. So a few of you may have a system prompt set up for your ChatGPT or your Claude, but every prompt that you're entering into that chat window is your user prompt. And the best way sometimes was just to do prompt engineering. For me, prompt engineering is really like, it's like one shot or few shot learning. It's like giving an example of what you expect and then say, now here's my question. And then the LLM kind of like, with the reasoning models, they got better at it. But over time, teams figured out that what they didn't need was a smarter model. Like they didn't need a better reasoning model and they didn't need bigger context. So like Gemini and like the new GPT has 1 million token context window, which is huge. And Llama 4's got like 10 million. But we found that teams are finding that's not what they need. You don't need more memory. What you need is better context, better focus on the task at hand. So in some ways, this context engineering LLMs are just kind of like a very fragile, like child in some ways. It's like you have to not distract them too much. You have to make sure that you enable them to focus on the task. So you give them exactly what they need. And so for me, that kind of encompasses the whole of data engineering. To me, in my mind, it was like, as a data engineer peering into this, I'm like, but this is really just data engineering for a more fragile, non-deterministic system.
Yes, it's interesting. I think with the whole context topic, that's something either because earlier people were wondering like, why does it forget things that I told it? It's just because it was basically purged out of the context, because then the context would have gotten too big, so that it's got lost. Or that's the problem, like you said, you have so much in there that the LM doesn't really know anymore what to do.
Yeah. I really like, how these terms like emerge is because you have all these people working on the same thing, and they all experience the same problem, and you need to give it a name. That's why these terms exist, right? And so you've got other terms out there in the market, like context poisoning. That's another one. That's when maybe you've seen like a hallucination, and then you ask the LLM, can you recheck it? And it says it rechecks it, but it comes back with the same answer. So that it's what teams have found is it's really difficult. Once something bad gets into the memory, it's really hard to purge it and make it overwrite it. So we're seeing lots of like interesting behaviors like that around context engineering. And how do you deal with that? It's like the LLM, like swap the LLM. I mean, some teams do that. They have a gateway in front, so you don't even know what the underlying LLM is. And they're like, right, we've detected there's some sort of attack or poisoning attack. We're going to flip it around, or we're going to purge the short-term memory. And so now it doesn't remember anything at all. And we can kind of try to start again by reconstructing it. And this is where I think we're going to see patterns emerge. It just made me think of like a really good use case for real-time and a technology like Kafka is. Kafka is great for replaying events again. And what if you had a poisoned context and you needed to reconstruct the context? How do you do that? You do that through replaying events again. And up until the point where it got poisoned, where you detected there was some sort of poisoning or attack. And I feel like, I just came up with that. I mean, it's just like, it's interesting. You could sit down in a room and think about all the problems we see in streaming land and data engineering land. And like, there are probably elegant solutions within the context of context engineering.
I mean, we all found that out when, especially in the earlier versions, when you created images with ChatGPT. You created an image and then it was putting something on it. I mean, the standard thing is the elephant. At some point there was an elephant there, and then you told it, no, remove the elephant, and it could not remove that stupid thing. Okay, because now basically it's poisoned. You can do nothing anymore. You need to start over because this will not go the other way. It's terrible.
And that created a brand new type of model, like actually like an image editing model became a thing, right? That's what we have with Nano Banana from Gemini. Like, it's not the best at generating new things, but it's great at editing images. And I feel like you're going to start getting these kind of LLMs with expertise. And I think maybe the future is a mixture of experts kind of model, and a model that can activate certain expertise depending on what's being asked of it. It just made me think of like one of the funniest examples was the CEO of Lenses. He took a picture of like a member of the team like visited the office, and he took a really nice picture, but it was against a really like bright sun in the background. And so he uploaded that to ChatGPT, and he asked it to, can you adjust the levels in this image so it looks better? And it just completely wiped it and generated a picture of a corgi, just a dog. And he said, whoa, that's a picture of a dog. What's happened? And then when you ask it that, it says, oh, I appear to have generated a picture of a dog when what you asked me to do was adjust the levels in an image. So it just goes to show like how bad this can get. And so, how do you go backwards from that? Once that's poisoned and you have a picture of a corgi, what do you do?
Before we go to Chankit's question here, I want to ask you, like you from a developer perspective, because you guys have done this for Lenses. Like, what were you specifically looking into this in terms of context engineering? What were some learnings from that you had in this?
Yeah, for me, we realized how much real-time context is important, because when we're working with LLMs and this interface, which is natural language, real time is kind of implicit in natural language. So, for example, let's say you, like Andreas, you were ill like 2 days ago, and you took medication, and now you're well today. And I ask you, how are you, Andreas? Your response can't be, I'm ill, I'm taking medication, right? Because like I didn't ask you what happened yesterday. I'm asking you what's happening right now. And the same thing, like which data engineering books have you ordered? I would expect when you answer to include the books that you ordered like a minute ago, up until a minute ago, rather than a day ago. So I feel that real-time context is very, very important when you're having a conversation. And this is kind of like where we're getting to with LLMs and MCP, that kind of implicit contract. So I think that's why there was so much excitement around, around the hackathon and our customers saying, right, we have customers that are saying we're going to plug, using MCP, we're going to plug real-time data and Kafka into all our systems. because it enables them to just do that little check. And so it turns out, and what I've really learned from all of this is most teams don't need stream processing. They don't need to look at every single event that comes in. They just need to look at the ones they care about. And so what do? You create pipelines, you build data context that is always queryable and always current. And so I think that's the biggest learning, really. It's like, don't force people to process the stream, because they'll say, well, I don't need real time. Like, I can live with the latency. But invariably, what they actually can't live with is stale data, like when they need it. And you never know when you need it. So a bit of an inversion in thinking there. Yeah. So, I mean, I spent many years trying to convince people to move to streaming through stream processing. And you get pushback for a number of reasons. Like, we don't need like low latency. There are so many reasons. But it turns out people do. They just don't know their own consumption patterns. And that's kind of like where I look at when I build any system. And I think I've been successful in data engineering in my career because I looked at consumption patterns. It's not always easy to ask someone what they want. Like, what dashboard do you want? Like, what kind of data model do you want? You just have to see how they're consuming the data. And I think AI engineering is very similar too. You got to look at how data is being requested. And I feel that with natural language, it's requested a lot more.
I need to quickly think about this because
I took months to think about this.
How does this
take
change?
Your time. Yeah.
Let's quickly let me order my thoughts, because what I'm usually saying to people and I'm coming from purely from the data engineering side here, not the AI engineering side. I always tell people, okay, don't start to build immediately, right? Understand what data do you have? What is the person actually going to do with it? Data analyst or the person from the business, doesn't matter. And then make the decision in between what to do. Right? Because you don't want to build a stream processing when somebody just wants to have a dashboard that every day gets used once. That's the idea behind it.
You're a good man.
just to be just to be general, like that's one of the rough things. So how would that change then for AI engineering? Let's say people have a natural language interface. So you would ask them, what data are you requesting and how? Like, what's the difference?
Yeah, it's interesting because it's the nuances. I feel it's like when you say all, that's like a select star. But is it? It's not. It's with limits, right? Because what is the current context of your conversation? If you're talking about the month of October, the select star actually is limited just to October. So I think teasing that out is the really difficult part. So yeah, I guess what I'm trying to figure out what I'm trying to say, but I guess it's as much as it is an art as it is like science in some ways. Because you have to like when you have something as fluid as language, you have to inject some sort of creativity to make it work. And sometimes you have an opportunity to delight someone in that case. And I think it's probably, there's a whole world of people waiting to be delighted by the fact that they have access to real-time data. And I think the penny like slowly will drop over time just because of this interface just naturally lends itself to it. And we don't have to talk about stream processing. You don't need to know about distributed systems. And this is really just building on all the good work that data engineering and system design has done already, which is to build a good abstraction already, which is a SQL interface, a SQL engine. So like as my colleague Drew would have demonstrated, like building that SQL engine from scratch, like came, like no one really does that these days. There's open source projects that you can build on. But to do that was a serious endeavor. And you just don't know where it will lead. Like no one could imagine AI was, the next kind of frontier. But now that it's arrived, we're enjoying the fruits of our labor. We're enjoying having access to this fast engine that is lightweight, doesn't require a cluster to run. Is very much like in microservices land. So I guess part of it is you never know where things are going to go. So you should always be learning, always be trying things out. I think, there's just so much going on. It's like almost impossible that like sometimes I sit down and I just excel very heavily. I'm like, oh, wow, like the amount of news. And internally, I send out like a week, every Friday, I do a weekly roundup of things that I've read that have been released in the last week. And it's just staggering how much I have to go through. Like my volume of what I have to read goes up every week. And it doesn't seem like it's going to stop. It's going to keep growing.
Yeah, that's true. Do we want to, before we talk more about these, do we want to look at the quick hands-on thing, or
Yeah, we could do
because
that.
I know you have brought on something with Claude to make this also a bit hands-on, a bit concrete.
Sure, yeah. Let me share that. I mean, I didn't want this to be about me demonstrating like how I type prompts into Claude at all. So I'll keep it really short. I mean, here's an example of the MCP server in action, like working with real-time data. And here, so the Lenses MCP service, it's on GitHub, it's open source, so you can use that with Lenses, and you can use it for free with the community version of Lenses. So if you have Kafka, you can attach it to that, or we have a Docker Compose that helps you to spin up a Kafka and all the bits you need as well. So for example, this MCP server is already loaded, so I'm going to just say list environments, and it's going to go away, and it's going to tell me what environments I have in Lenses. So environments are just how you can almost consider an environment like a cluster of Kafka. Like it'll be your production cluster, for example, or your staging cluster. And here I've just got one in Community Edition. We just shipped one for an example. So one example you might ask is, I think one of the things I always had to do, I worked in a compliance team when I was a data engineer, and it's like finding things like sales orders. So you might say, where do I have sales orders in Kafka? Like ordinarily, you'd have to go through each topic or look in a data catalog and fill it out. So right now, using MCP, you can just have a conversation with your data. It's interesting because it could be hidden quite deep in the metadata as well, and it'd figure it out. Here, it's found a topic that appears to contain sales order data. Like, I mean, this is actually a naming convention from SAP systems. Like, so for someone who doesn't have experience with SAP much, you wouldn't know that, but LLMs with the knowledge of the internet and invariably SAP as well, it knew this and it's able to flag that. It's also trying to please you and ask you what else you should do. So you can verify that. So we've got a simple way to just show me one event. That's kind of like a select query under the hood. And then it's going to show me an event. And you could do interesting other things after this. Oh, we'll let it execute first. So here's, and you can ask for as many as you want. I'm just asking for one event. So it's really useful there. You can look at health. So if you're like a platform engineer, you can start thinking about partition distribution, because obviously having hot partitions is not good because all your data is clustered into the same partition. So it's able to do these things. So under the hood, it's calling an API, a Lenses API that does that, and it's showing you the distribution. And this is just a joy to use because rather than navigating a bespoke UI, you're able to start designing your own or have your own tool use its own way of representing that data. When you want to start looking at lots of topics, like if you have many, many topics, you might try to understand what's going on there. Now, in these topics, they usually don't have a description. There's no tagging or anything like that. And you want to know what are your sensitive topics. So to be able to do that, again, you can ask the LLM. You ask it to describe each of the topics in a single sentence, and then it's going to go and do that. And then you want to figure out which one of these look like they have sensitive data in it, like PII data. So now under the hood, what it's doing is it's making some SQL calls to each of the, it's sampling the data inside each of the topics there. So I've got, I think, like 8 or so topics. So it's going to go away and do that. And then you're going to be able to, then get this summary. I think the important takeaway here is that the LLM's kind of doing the reasoning and the thinking for you. And that frees you up to basically just, it turns into, rather than a creative and a thinking and a coding exercise for you as the engineer, it turns into more of a validation or a checking kind of exercise. And we all know that that requires fewer clock cycles. And I think one of the things that I think made me successful in my data engineering career was really being able to share everything I learned so that everyone else could be on the same page with me. And that frees me up to go work on more interesting problems. And
True.
I built my career on contracting, and you always met two types of contractor. The one that was, you've probably met these personas. One that was extremely secretive, didn't want to give up any of the information, and they thought they were creating job security for themselves, right? But they were actually creating a cage around themselves. And I went the other way. I just shared everything I knew. I tried to make myself redundant because I always wanted to move on to the next contract and work on the next new thing. And so this is kind of like what it's doing. It's freeing you up to think and start identifying new problems. So here, it's identified here are some sensitive topics, and then you can run queries now from here that will enable you to then go in and update the metadata. For example, like we don't need to see the output. I can switch to Lenses and show you, but like kind of it's a real thing. Like you can update this metadata now. So take the sentences that you've generated, and wherever it's sensitive, tag those topics. So it's going to go away and it's going to do that. So yeah, this is kind of like a simple automation that kind of helps you in your day-to-day. But also if you need to develop, let's say, an agentic system that needs to do these things, you can start off there in the terminal. And here I'm using Claude because it's just nicer to demonstrate. But you could be doing this in Cursor, in your AI-assisted IDE. And I think that's just the natural evolution of things. It's no accident that we have an embedded terminal inside our IDE. It's because you just work faster in a terminal without a UI. Keyboard warrior. You just keep your hands on the keyboard. Yeah. And this is just an evolution of that.
I think this fits very well to the topic that we were talking earlier, to the whole vibe coding topic, because or vibe coding / having that information or having that piece not live so long. Because when we think about it, some things we saw here, especially in the beginning, about what's the status of the cluster and so on, these kind of things that you most likely have in an interface, in a dashboard, is something very straightforward. And most likely it also makes sense to keep it there, except you have other systems you want to dock on and easily use that information as well. But then, you know how it is. Then there's a problem. There's something specific that you want to find out. And then you need to go in and, what commands do I need to do? How do I get to the systems? And then...
Yeah, you need knowledge of the whole ecosystem, right? Yeah, we burn a lot of time doing that, right?
And so this way you could just pop up a chat, ask it. There's no coding involved. There's no going to the systems. There's no finding out which commands to use. It's just, okay, this is it. Give me the information. Boom, done. And then once I have it, okay, let's move on. Forget about it. Just like you said with vibe coding, let's forget about it. Now I have the information.
Yeah. And not just vibe coding, but if you take that mindset and you apply it to just data engineering and systems, you'll slowly see this kind of approach start to replace some ETL or ELT jobs. Because what do you need to do ETL, and what is mainly a data engineer's job, is to move data almost into a central location so that you can process it together. But with agentic systems, the data can live where it is. So MCP servers are that gateway. It's essentially the keys to get into that system in its place where it is. So you don't need to move all the data to get those insights. You can send the agent there, almost like a human. You're sending a human there to get that insight. And so I think we'll see that shift where in data engineering, you'll get that overlap where you'll have your traditional pipelines, which are deterministic and work as we expect, but you'll also have some data that cannot be moved or should not be moved for whatever reason, sovereign reasons, policy reasons. And the only way to get at that data will be through an agent. And so I think we'll see an evolution here in data pipelines where there are moments where it has to go a little bit open world, call it off-road, whatever you will, but it needs to go and find that data in its place. And I think there's probably going to be, I'm going to see a lot more of this probably in the next 12 months. I see that with some of the teams out there that I visit, that they're going to leave the data where it is. They don't want to pay to put it in a warehouse. There are great technologies like Apache Iceberg that makes that cheaper as well, putting it into object storage. So we're going to see it's great to have options, right? And so it's good to learn about these things and explore them and try them for yourselves.
Yeah. It's also, like you said before, this way you enable people to actually use the information that is in your stream processing, in your message queue. Others might not need it, but this way they can just dock on onto the MCP server and get the information. The information stays there. We're not creating another silo, another bunch of tables, another bunch of files in the lake. We're just giving them the information or the access to the data.
Yeah.
That is maybe already there.
Exactly. And I'm seeing like interesting patterns in the AI engineering world as well for this. So MCP, the next major spec for that's going to come out in about a month's time. It's around, I think, the 25th of November. One of the things that it aims to improve is essentially a better polling system. So we have agents out there that people have deployed, which run for 8 hours, like many hours. And you need to know when they're finished processing their jobs so that you can retrieve the results. So it's a polling mechanism. But in my mind, that feels like an event-driven mechanism. Like you send it off and you wait for an event to come in somewhere in a system like Kafka to tell you that job is done. And now you can go and fetch the data from, you can even in the payload have the URL or the location of where to fetch that data. And I feel like that's a better system. And yet where it ends with this batch world, even in a world as new as AI engineering. So I think the evolution of this is going to be very interesting. And I don't know what the answer is. I'm going to keep trying. I'm going to keep sharing what I learn. And I think we'll find some very interesting patterns in the next 12 months for sure.
I think especially for streaming, it's a very interesting concept because if you're just interested in the fresh data and not into the old, like you could say, okay, I'm using a Kafka message queue. I set the retention to 2 days or a day. Doesn't matter how fresh you want it. And then I have the MCP server on top, and I have agents actually using that MCP server, or my users using that through cloud. And there they only have access to the fresh data, nothing old. The context doesn't get spammed with some other things. When we think about RAG systems, they might return documents that are older, stuff that you don't need. And this way, this just is fresh. It's just the fresh data, nothing old. It's very interesting.
Yeah, about a year ago, I talked about real-time RAG. It's just when you're continuously vectorizing, continuously embedding, rather than doing it as a batch. So that means, a common use case would be a customer services agent. Like if someone's contacting you or the chatbot in this case and saying like, oh, my order, which they just put through, got declined. If you have to wait for a batch system to catch that up, that's not going to work. They're going to say, try again later or come back in an hour, whenever that is. But to have that information in real time is interesting. And there are a lot of real-time use cases for this when you get into it. So real-time RAG, I think, has some adoption. It's not the most popular thing because I think people don't believe in what you just said, which is that maybe you don't want to pollute that context with the older records. It's essentially doing like a retrieval, like a top K, and it's saying these 5 documents. It doesn't matter where in history they come from. They're relevant. And so like being able to have like additional ranking with that would make sense. But the difference between the first and the second could be so huge. There's no way of discerning that. So you just hope for something better. And real time, sometimes it's in the recall, right? It's in that metric. You say, right, we're not going to recall these others because they're so stale, but these are fresh, and we're going to recall these. And so I think that's kind of how data engineering probably will evolve.
And also, you don't need to have the embedding there. If the data is very structured, just like you shown in that example, most data in the context of e-commerce, right? Somebody makes a purchase and that purchase lands into the message queue, and then they can ask the chatbot about that purchase. It's very structured data. You don't need to embed it, like create embeddings. You can basically just use SQL and get the results. So that's very cool.
Yeah, it's no surprise that databases, teams or vendors for databases built MCP servers. They're quite quick to get on it because we already had a natural query engine. It was really about translating natural language into SQL. And that's a fairly well understood challenge.
As long as that works, there was a question which which LLM model would be the best for in that context, because then if your data is very structured, that model should not mess up the SQL code creation.
This is the bit where Anthropic send me some swag for preparing their model. I mean, I can only speak about the models I've used, and I've used like nearly all of them. On any given week, it will be a different one. Today, I'm using Claude. Last week, I was using something else. I mean, it depends. You can go to, there are places that publish benchmarks. I can probably put them in the show notes, but like LM Arena is one of them, and they rank all the latest models for different criteria, like, you know, image editing, image generation, web development's one of them, and there's another one for, I think, just general like coding, like as a copilot. So yeah, I think Gemini's up there. I use Gemini quite a bit. It's got 1 million context window, whether that matters or not, as we've learned. But I feel that it kind of understands when I speak to it. That's the easiest way I think I can put it.
Interesting. Until now, I was a ChatGPT guy. So
exactly, yeah. I think many of us were.
Yeah, but I think Google is doing good work here. They are.
Yeah, I think it's almost like a 2 or 3 horse race. Like every time someone releases something, you just wait in anticipation for their competitor to bring out a model that will outperform them on a benchmark. And so, does it become are they trying to actually get better, and they're accidentally performing better, or are they just trying to game it? Like, who knows?
I don't know. That whole training LLMs part, that's beyond me right now. I have no actual knowledge how this is done. So, there was a question again, where is it most effective supervising the system? Error detection. I mean, error detection, we've saw this. It's really that kind of thing where you're just querying where are some errors in my service.
Things like anomaly detection, things like that. It can figure out patterns. Like, okay, LLMs are terrible at math, so don't get it to do anything mathematical. I think all of the above in your question, really. I think they all work really well. I think there are whole movements around like system design, like AWS's coding agent called Kiro. It's like a little ghost logo, if you've forgotten what that looks like. They're based on specs-driven development. So you can't actually get it to generate code until you've written it as spec. And so the fun part is you can vibe spec, like you can vibe and create a spec, but once you have the spec, it implements it. And so there are whole teams that really believe in that form of development. Sounds a lot like test-driven development or TDD, or writing Cucumber or Gherkin, like if you remember business domain-driven development. So I think everyone's kind of approaching it in a different way. And so it's hard to say which is best, because it's down to the prompt, it's down to like the LLM. It's seemingly, what you've already been asking it previously. It's just, there are so many variables. So the best is the one that works the best for you. And this because you've tried a few. That's the answer, I think.
That's true. There are systems, or really vendors, who have systems to check. You were talking about LLM Arena. I never used that. Maybe that's kind of a thing that you can use, but there are also previous partners that I have worked with that have kind of a system where you can do a prompt, have some data, and see what comes out of it with different LLMs. So that's interesting. Yeah, for the whole topic of, let me bring that up again, supervising the system or error detection. One thing I'm hoping that LLMs help us is removing that we're getting a lot of false positives. Like, I remember when I was working in predictive analytics, where we were basically monitoring systems and trying to find out if they break or when they break, instead of just setting alarms at that threshold, and then you get the alarms and you always get false positives, and like, ugh.
Always, yeah.
So my hope is that these systems can help us there to actually see, okay, I have an error here regarding the context, not just the error does that make sense? Or is it already performing normal again, and that was not really an error, and I'm not going to send that out? Those kind of things, I think, would be super cool.
Yeah, we used to I worked previously for a company that dealt with a lot of telemetry data, and that was the number one use case, like anomaly detection. And we would solve that through other means, not using AI at all, like downsampling, for example. Like if you reduce the fidelity of that data, then those spiky bits just disappear. But if they're sustained spikes, they're long-lived, they stick around in the data. So yeah. I will say that there's a lot of active research and promising results around LLM as a judge, as a concept. So that's when you have a downstream agent in the loop that will check the results of the LLM. That's been proven to be really good, because that's usually something that you can give with a very defined scope, or you have a set of judges which all look after like a specific use case. And that seems to be having really good results. So maybe one of those is a detection or based on like recent history, and another one checks for like much longer history. Another one checks the model of, that motor, which, is known to fail. And there are different ways. And I think you can get really creative with these systems.
There's actually someone in the chat that knows you.
Yeah. Oh, wow. Yeah. Yeah, we went to high school together a long time ago.
Oh, nice.
Yeah, interesting. Yeah, we've chatted enough over the years, so it wasn't like, yeah, interesting. Wow. Yeah, I'm not going to say how many years ago. That would be telling. But it was before, it was just as I was getting started with software engineering. Let's leave it at that.
Okay.
Yeah, but yeah, everyone's interested in AI apparently, so here we
go. We had on our list from yesterday, we had a few other topics. We might wanted to look at FastMCP. I don't know.
Oh, right. Yeah. I mean, we didn't dig into the code here. I mean, the code is open source. Yeah. I think we have in our description the link to the GitHub repo, so you can check it out there. In short, use FastMCP. It's a great abstraction for Python over the MCP, like over the protocol. So you don't have to, it's a really good abstraction. And the basic abstraction in MCP is just you have tools, you have resources, and you have prompts. And I love that it uses decorators and a way to like create them very easily from your functions. So rather than show you what it looks like, I implore you to go and check it out and try building with it. So much so that it got adopted by by Anthropic's, like the Python SDK was adopted. It's going through a thing where it's trying to have feature parity in versioning and stuff. We won't go into that. That's a whole other topic. But like it's been popular because it was such a popular abstraction. So yeah, a lot of MCP servers written in Python would be using FastMCP. And we use it at Lenses, and I recommend it.
Okay. That's something for me to look at for my students. I trust you there.
They'll appreciate that, I'm sure. Yeah. You'll be like, folks, this is new. Like, we're cutting edge. It's only 11 months old, but here we go.
I mean, the concept is important, and once you have the foundation, using some abstraction is good, I think. And then you're also able to switch to another one if something other.
Yeah, and it's lightweight. Yeah. We love that. It's so like you want to look at the code and really understand it, and I think anyone will be able to follow along. It's really straightforward. Yeah.
Did you have? I'm looking at my list. Real world use cases. Did you have a few others that you wanted to talk about?
Yeah, I think I just like the ones that I talked about. I mean, the deeper, more complex use cases would be around building like actual pipelines of processing that do things. A very common component in the world of Kafka is building connectors. So connectors that will source data or sync data to a destination. That often requires like a lot of config, and it's different for each type of connector, as you can imagine. If it's a database, it's going to be different to S3. And just having knowledge of that DSL, all those parameters, is often like a lot of reading, a lot of trial and error. But doing it through AI assistants is like it's a joy, because you don't need to learn every new DSL. You just apply your system thinking to it. The DSL, the name of the parameters, what they are, it doesn't really matter. They could change day to day. But what matters is that you're looking for a partitioning strategy. You're looking for like how long to wait for a message. All those things that you'll learn from first principles will be applied here. Someone who's vibe coding won't know all these things and will just accept what they're given. But with good knowledge of system design, you would be able to tune that and make your prompt, engineer your prompt better, or ask it to iterate specifically what you want. So yeah, I would say that those are the biggest, like for onboarding new members of the team, anything that requires knowledge of a DSL, like AI assistance is fantastic for that.
Yeah. Also, even if you don't have the knowledge, you can actually ask the system, and it can give you options how you can improve performance, how you can.
Right. Yeah. I'll give you a really good recent example. For the hackathon, we wanted to create an environment for the teams, and we wanted to do it using Terraform, so using infrastructure as code. And the default was to just bring up 15 of, of like a remote MCP server. And it's like, okay, I mean, if you didn't tell it how many we needed based on our knowledge of how many, how you load balance, etc., we could have just let it get away with doing whatever it wanted. So again, that's like Terraform HCL. That's another DSL you'd have to learn. But if you understood like the underlying like infrastructure, how it should look, like you're able to guide that so much better. So everyone should try that. Everyone should try AI assisted development. They'll find the joy in programming again, I think.
Yeah. As long as you really take care of what is it doing, and not just press yes, make the changes, yes, make the changes, yes, make the changes. Let me quickly. I want to quickly check. Which links do we have in our description here?
Right, that's a good question. So
People
I know.
Can.
Yeah, we're actually having a big launch today on all of this. So you'll probably see some videos of me appear around the internet.
Nice.
But the Lenses IO GitHub, which has the Lenses MCP server there, that's going to be an ongoing project that we're going to, like, as each new spec comes out. I think next on the roadmap is implementing OAuth. So right now it's token based, like using a bearer token to authenticate. We want to, like, OAuth is just so much better, like for many reasons, like, key rotation, all that stuff, having better scoping around your policies. So we're going to implement that. And then, we're going to go into building agentic systems on top of MCP. So I think this was just a really great foundational kind of technology to build, just so we can, build for the next like couple of years at least, I hope.
Yeah, that's true, because once you have that foundation, you can really figure out, okay, what do the customers, I'm thinking about from Lenses perspective, what does the customer actually need? What are their typical problems? And then you can just build agents or build systems on top of that.
Yeah. Right. And when you look at the code, you'll see that we have implemented, it's very loosely a wrapper around the RESTful API that we already had. But over time, that will change too, because I think the best MCP servers don't enable you to have very chatty, loads and loads of calls to achieve a single intent. You should be able to achieve that with just one tool call. And that's where we're going to get to over time as our customers adopt it, as the community adopts it. So I would implore everyone to check it out. At the very least, give us a star, just so we have some visibility. And if you want to go even further, try it out and send in a GitHub issue. I think those are always the most fun.
Okay. Yeah, that's true. Because then
there's going to be issues. It's software.
Yeah, it's normal.
We welcome it.
We're here. We're still talking about software development, and that is never perfect.
I remember. 4GL is going to solve everything. Low code. Yeah. I mean.
Yeah.
This is yet another one of those that people will claim will solve it, which we know. But the thing hasn't changed. That hasn't changed is the community around it, and like opening issues, having conversations about better design, fixing things in open source. Like, those are the things I think will stand the test of time.
All right, Tun. Again, everybody, check out in the description. There are links to the Lenses MCP GitHub. There's also to the Lenses website specifically for the topic that we were just talking about, AI assisted engineering. Tun, thanks a lot for
Thank you, Andreas.
being here. For me, this, as I told you yesterday, I'm also still learning here. So for me, this is very important and very interesting. And very often it's like something like, oh, okay, I can get this together with something that I have done or that I have experienced before. And then like the circle closes and it's like,
So yeah, I really appreciate that. Yeah, and I really enjoyed this chat. And I don't often get to speak to seasoned data engineers, and certainly not have an audience for that. It's been a little while, I guess. So it's really nice to be back and to be talking about these and how they relate to where this is going. So yeah, really enjoyed this.
Yeah, me too. Tun, thanks again. Everybody, look up Tun on LinkedIn and give him a follow. And then, thanks. And see you later.
Thanks, and see you soon.
Bye.
Bye.